I think that now we can start our second part of online conference. I'm glad to see you all here with us. And today we are going to have 8 reports dedicated to digitalization of society, economy, management, and education. And now I would like to remind the common rules of today's presentations. So speakers are given 10 minutes for presentations. And in order to follow our schedule, in order to respect following speakers, I will let you know before 1 minute left, just say like 1 minute. So many, my apologies in advance. After 10 minutes, we will have 5 minutes for answers to questions. So while the first team is preparing their presentation, you may start sharing your screen. I will introduce them to all of us. So the first speakers are Christina Knox from the University of Queensland, Australia, Irina Boychenko and Galina Platunina from Moscow Technical University of Communications and Informatics. And the topic of their report is Interactive Built Environment Technologies in Smart City Design, Connecting Society and the City. So, as I see, you are almost ready. Good. So, if you are ready, I put my timer on, and please be welcome. Okay, microphone, please. Okay, yes.
Okay, am I on now? Can you see the screen?
Yes, absolutely.
Okay, that's perfect. Let's begin if that's okay. So my name is Christina Knox, and I'm completing my PhD in the University of Queensland in Brisbane, Australia. And today I will present my paper about interactive built environment technologies in smart city design, and it's about connecting society and the city. So from ancient pyramids to modern built environment, buildings have been designed and constructed in relationship to a variety of changing factors, including climate, use character, setting, culture, and environment. Within the realm of social conditions are one of the key factors subject to dramatic changes that has significant impact on built space and the way users occupy it. At the same time, built space has a role in social relationship that can have different degree of influence depending on other factors. The social conditions change with rapidly growing and digitally mediated environment, and so do the building topologies, becoming interchangeable and developing a universal type of space that is able to accommodate various topologies at the same time. This shift has happened due to entering the era of cyberspace and dematerialization of the world around us. This new type of space requires specific mobility and flexibility in order to create the architectural environment that would successfully satisfy the evolving needs and psychological, physical, social, and environmental demands of the society. It uses modern and constantly developing technologies, exploring new methods and applications that enable the space to reach new qualities, becoming dynamic, responding, and active, and therefore truly interactive. So interactive built space, or architecture as I call it, arises from exploring and understanding what the space, structure, or a whole building is doing and how it can perform its task better, and therefore contribute to the development of smart city. It suggests numerous benefits like the enhancement of the building ability to meet functional demands, its security, flexibility, and adaptability, image, reliability, energy consumption, expenses and costs, and easiness in using it. Optimization is of visual, acoustic, thermal, and or other conditions meeting the change requirements in public and private space, satisfying spatial needs and desires of users, and other tasks can be achieved with means of dynamic, responsive built systems. It is the answer to how the built space can help the inhabitants to perform their activities and tasks better, or give advice on how to use the space in a more effective or efficient and sometimes unexpected ways, or provide them with more suitable conditions for their current tasks. Interactive built space is based on the concept of bidirectional communication, which requires two active parties and not merely the ability of the built space to adopt. Interactive space is the art of building the relationship and communication of its components between each other and between the users. Oops, I will have to jump this one. So therefore, in the social realm and in urban context, people communicate with people. But then with development of smart building technologies, building components are also able to communicate between each other and transmit and process various information and data chunks. And eventually they learn the common language to communicate with each other, and therefore building elements communicate with people, creating this very immersive and engaging environment between people and space. Moreover, interactive space can be used not only as a facilitator of people's social interaction, but also become a participant of this interaction. So essential role of built space here is considered as accommodating human needs and ability of the space to shape user activities, affecting their behavior and experience through spatial systems, modifications, and kinetic spatial components. Interaction within the built environment is perceived as a simple input-output dialogue, while input signals create an output or a reaction in real time. So interactive space within the discourse of my presentation today is versatile, and users' behavior performs as input signals to satisfy a need, and the spatial reactions are the output. I will have to jump a little bit further now. So a smart city in this context is a city or a part of one which has adopted digital technology to provide a better environment to residents, businesses, and local government. In many cases, interactive technology is leading the way to the possibilities of what smart city can deliver. According to the Royal Institute of Chartered Surveyors, some of the crucial sectors that harness the smart city concept include energy, water, and transportation. After a decade or even more of trial and error, municipal leaders are realizing that smart city strategies start with people, but not technologies. So therefore, smartness is not about installing digital interfaces in traditional infrastructure or streamlining city operations. It is also about using technology and data purposefully to make better decisions and deliver a better quality of life. Quality of life has many dimensions, from the air residents breathe to how safe they feel walking the streets. The latest report from McKinsey Global Institute says that digital solutions for more livable future analyzes how dozens of digital applications address this kind of practical and very human concerns. It finds that cities can use smart technologies to improve some key quality of life indications by 10 to 30%, numbers that translate into lives saved, fewer crime incidents, shorter commutes, a reduced health burden, and carbon emissions averted. An example of similar behavior, but dated way back to the early 1970s, is the two Lumiere cybernetique made by Nicholas Schoeffer in 1974. It's the light space modulator of his predecessor. Schoeffer's project was based on light and sound sculptures, receiving signals and external sources and translating them into kinetic responses. Schoeffer's research and experiments aimed to release art forms from their traditional constraints, combining various art disciplines into one experience. He merged non-material spatial components, integrating light and time with the tangible art forms that accommodated them, like built space, projection, film, dance, and written or verbal communication. His experiments encouraged the comprehending of a collective choreography of visual and sound urban components involving creative communication between the arts and the audience, which translated into the city. Interactive behavior is different compared to prescribed or responsive within our Discord due to its ability to create personalized communication with its users in real time. It can be achieved directly by means of digital interface or implicitly by using embedded microprocessors, input from sensors, and less direct input that needs to be interpreted. In terms of communication, logically follows the principles of a dialogue, with information being received, processed, and interpreted or translated, defining the behavior, change, or an action. And the new age of technological advances makes translated data and tailored knowledge a valuable resource, while the electronic form, such as internet, gaming, mobile devices, smart robotics, etc., has become a quintessential element of modern life. People become users requiring customization and personalization on every level, creating their own very special experience of objects that surround them, which includes the built space and the environment. One of the more recent projects involving integrative behavior on a social level is the Urban Scan project in London. It's an interactive public space video installation that detects passersby, tracks them, and projects video.
1 minute.
Of the previously recorded participants. One of my last slides is another project by Osterhuis. It's called the Graphisoft Slider, and it's a set of programmable Slider volumes demonstrating unique and not yet experienced structural behavior. The main idea of this project relies on retaining the autocomplete slider, but the idea behind it is that urban scale projects have changed according to the new trends as well. Traditional city concept is now influenced by trends of a hyper city, where new shops grow up and replace the older ones, where old squares disappear to give way to new prospects and perspective, and therefore improving the social interaction and maintenance infrastructure of the city. But environment and public space are important participants of the social relationships. The state of transformation is enhanced and supported by a network of information connections. A building, a city, an airport, a car, a human have become one of not of the vertex of the whole system. And thank you very much. This is the end of my presentation.
Thank you so much for your presentation. Now it's our time, 5 minutes for questions, and I turn the floor over to Professor Peter Pamphilov, who is chairman of today's session. Peter, please. Do we have some questions to Christina? Don't hesitate, please. Any participants may also ask questions.
I can talk more if you'd like, if we have some time.
So if there is no question, Peter, don't you have? You have questions.
I just skipped through a couple of moments. I could come back to that.
Okay, I think that there is some issue with his microphone. You have to unmute it, Peter. Unmute it here. Unmute it like here. No, we can't hear you. Okay.
Strange.
Okay, we can. Got you.
Can you hear me?
Yes.
Oh, great. Okay, so what is my question? You know, you mentioned this interactive architecture. So we know we're talking about architecture, we're talking about number of components and how they interact with each other. And from distributed system perspective, it is important to define what kind of interfaces we can build between different components. So to provide some scalability of the system and some other important features. So did you consider this aspect? You mentioned several times digital interfaces, but what kind of interfaces we can consider in this, I don't know, smart city environment?
The main thing here is that it's very scalable and that it allows multiple possibilities. To begin with, build space can act as medium itself if it has appropriate hardware, and it can translate images or sounds or light or information translated through the sounds of light or light. If it just has basically LEDs are the basic form of this communication, which can be developed further and further. Other than that, it cannot be just a medium such as, we can say it's basically a screen, but it's not the limit of it. It can also be a facilitator which offers different types of communication with the society. It can reflect the social mood. It can reflect the way society should feel. It can inform society about different things. So it can be applied from the scale of people directly communicating with it, when the build space itself has some form of receiving device, such as sensors or any other receiving devices, to a little bit more application requiring forms of communication, when users input some kind of data, when they share some kind of information, which is then gathered, processed, and translated and turned into some kind of visual, acoustic, or kinetic effect by the build space. And furthermore, different environments communicate with themselves. So we now can link different remote environments between each other and see what happens somewhere else, to somebody else, or to some other location. So therefore, there is basically no limit to this, and the application of it is very universal. It only depends on the necessity in the current context. Does this answer the question?
Yeah, partially, but focus here on the user interface, or what about interface between different systems? So, you know, in distributed systems, we have two approaches how to build interactions or communications between different components. It's something like a broker, central unit that coordinates all communications between different parts, or it can be a wrapper when we have some kind of special interface device that provides communication from one component to other components. So from this architectural standpoint, what is important in your proposed solution to interactive architecture of this smart city environment?
I'd say, based on the experience and on the case studies I have considered myself, distributed adaptive control is the most applicable solution to that, because it allows control of multiple different elements. But then on the smaller scale, or depending on the context again, it can be centralized control. So it really depends on the context here. So on the urban level, again, it depends on how many components we're talking about and what is their relation to each other, because sometimes we don't really need different environments to talk between each other. We need them to address the user specifically. So in this case scenario, they don't need to exchange data with other environments. So they can concentrate on what happens here and now. While sometimes, yeah, it has to be networked through other buildings as well. It's very open question, and each solution to apply interactive technologies to built environments will depend heavily on specific objectives and tasks. So there is no one answer here. It's
absolutely. Different environments. It can be a small environment with a limited number of components or elements, and it can be a huge environment. Yeah, smart city. It can be just a smart town, or it can be smart capital. I would say. Okay. Thank you very much.
Thank you.
No more questions from my side. So, any other questions from the audience? If not, we can move on.
Okay. So, last chance to ask question. If there is no question, so we can move on, just in order to respect our schedule. Thank you so much, Christina. Thank you
very much.
Thank you. It was a great pleasure to have you today with us. And while our next speakers are preparing to share their presentation on screen, I'm glad to introduce them. So the next speakers are Elena Stroganova, Sergei Grichkin, Evelyn Bushuev from Moscow Technical University of Communications and Informatics. And the topic of their report is Smart City, Electromagnetic Safety Problem. So let me remind you that you are given 10 minutes for your presentation, and I will let you know before 1 minute left, and then will be a 5-minute session for answer questions to the question. Okay, so Elena.
Hello.
Hello, hello.
Hello.
So we can see.
Our team is from Moscow Technical University of Communication and Informatics, and the matter of our topic is Smart City Electromagnetic Safety Problem. This is very important question, and it's the time that we must do our make attention that this problem, because the smart city is this is the narrowest future. So first, the first problem is the smart city is a very big concentration of telecommunication technologies. The current state of society is characterized by a high level of technical equipment in all spheres of life, and one of the key elements are a life support system associated both directly with human and with transport, industrial zones, energy facilities, and so on. The functioning of such system is impossible without modern networks and communications facilities, and in practice, technical systems and telecommunication systems are always closely related. For such systems, a particularly significant characteristic is reliability, as the probabilities of an object to keep in time within the established limits, the values of all parameters characterizing the ability to perform the required function in specific modes and conditions of use. The smart city is a combination of telecommunication technologies, the Internet of Things, databases, and information systems, which contributed to the digitalization of life management in the city, both from the point of view of the life of citizens, including a smart home for them, and automated workplace for workers of cities services, as well as all city life supports systems. A high concentration of equipment and systems, including radio communication, leads to high levels of electromagnetic interface in a smart city. In the smart city, the problem of ensuring electromagnetic compatibility of equipment, EMC, is in short, and telecommunication system arises. Communications equipment and systems through their entire service life are exposed to various types of electromagnetic influence. Failure to comply with EMC conditions leads to equipment damage, incorrect actions, failures, unnecessary or false alarms, and so on, of protection devices, in selection overlap, malfunction of automated workstations of personnel, etc. Significantly reduce the work reliability. The criterion for fulfilling the MC condition is to ensure an electromagnetic environment in which the highest possible levels of electromagnetic influence of all types at the facility do not exceed the permissible values for specific equipment. Due to the fact that the continuous and full functioning of technical means in the electromagnetic environment of the smart city and the limitation of unacceptable electromagnetic interference caused by technical means are a mandatory condition for the implementation of the smart city concept. Consideration of the problem of electromagnetic safety of a smart city is required. Looking at the concept of smart city, both in the creation of new cities and in the modernization of existing cities, the problems associated with electromagnetic safety, both for humans and for electrical and telecommunication equipment, include in the smart city systems follow. Example of electromagnetic safety problems for humans. Round-the-clock exposure of electromagnetic fields from the early morning to early morning, include nights and so on. Exposure to electromagnetic fields in new frequency ranges, for example, very high frequencies with terahertz, for example, or very low frequencies. Management of safe human activities, control of devices and mechanisms that affects human safety, assessment of the risk of harm, established the sanitary and hygienic standards, taking into account risk assessment. Example of electromagnetic safety problems for technical means and systems. Establishing assessment of the functioning of technical means about new electromagnetic environment. Assessment of the functioning on convergence systems. Development of testing methods. Risk assessment and established of standards for electromagnetic compatibility. It's necessary to develop recommendation regarding the principle that can be applied when planning and implementation measures to ensure the electromagnetic safety of both humans and technical means of a smart city. The work this work has begun in our country. As part of our research, recommendations have been proposed for some assessing and mitigating the risks associated with the electromagnetic safety of the smart city. Thank you for attention.
Okay, thank you so much, Elena. So you saved 1 minute, and it can be a plus to your session for answers to question. Dear Peter, do you have questions?
Okay, can you hear me?
Yes.
Yes,
I hope so. Okay, good. So any questions in the audience? Do we have? So we are talking, I have questions, of course. Electromagnetic safety, it's really a problem, but you know, this problem is different when we indoor and when we are outdoor. Smart city, it's an environment when we have a lot of problems inside buildings, inside different kind of facilities, shops, etc. But at the same time, we are subjected to electromagnetic fields outside. So, and measures should be different. How to deal with this different kind of, I don't know, electromagnetic environment that we are subjected to.
The electromagnetic environment are different, but there are both problems inside homes and outside. They are different, but they both exist. For example, you have medical devices on you, and you are at home, and then you go to the street, and electromagnetic fields there are around you. And they are different, but problems exist.
Yeah, problem exists, I know. And you mentioned that we need something like new standards, new recommendations, but
Yes,
we know that all kind of equipment that we use in our houses, all these, I don't know, home appliances, they all are designed and developed and manufactured according to standards. So what is missing? So what do we need to develop new?
Okay. Every device has their own certificate for electromagnetic compatibility. For electromagnetic compatibility, every one device, because our existing methods are for individual device, not the systems, convergent systems with human devices in these systems. I show you the one of pictures. Here you have very many certificates, but there is no safety environments for human and for devices. For example, you can have smart drive systems and another devices in the car and in the road systems, and they are they work совместно, they worked in whole, and this problem is not is not studied now. The systems in whole is not studied now, but this task began to begin to begin to study. So we have 3 standards for a smart city in Russia. These standards have some interesting elements, but these problems must be studied more, because our life is more and more smart. and so we can we must to study all the risks and system convergence and all the problems with human and the influence of electromagnetic fields for its for human bodies now and so on is now standardization for these problems, but this standardization is not enough for modern conditions. That I want to
okay. To summarize,
yes.
we are living in a
Yes.
smart environment. Environment is getting smarter and smarter.
Yes.
We should be smarter as well.
Yes.
Okay. Okay. Also, your
Yes,
turn.
Thank you, Elena. Thank you for your report.
Thank you.
So while our next speaker is preparing, let me introduce him. It's Konstantin Pavluchenko from High School of Economics, Russia, and the topic of his report is Predictive Analytics for FMCG Industry. Konstantin, do you with us?
Yes, yeah. I'm here.
Okay.
Do you see my screen?
Yes, we can see your screen. We can hear you.
Yeah,
so
okay.
You have, yes, let me remind you that you have 10 minutes for presentation, and before 1 minute left, I will let you know, just like 1 minute, and then will be 5 minutes for questions. And if you are ready, you may start.
Okay, thank you. This is Konstantin speaking, and I want to introduce my study about using predictive analytics in FMCG company where I work, especially in the sales planning business process. So let me show the small agenda of the presentation, and we start. Like I start my presentation with the actually introducing and some goals and results. So the main goal in this work is actually we focus on demand forecasting problem, and we use the data from some company like X. It's the anonymous company for this study. But we can say that the company produced a tobacco product. It's a company located in Russia, and actually this is the tobacco market. So the main goal, as you can see, is we try to improve the accuracy and the effectiveness of the forecasting. We set the next task for us, and we have the hypothesis of the study that predicting analysis can improve actually the efficiency of this business process, and brings benefits to the company in more accurate forecasting and optimization the stock and the shipment values. And the result of this work that we make the application for the product manager. So with it, he can work with the forecasting values with some predictions, and it brings more benefit than without this application. So if we can talk more close to the study, so here you can see the business model from the logistic point of view, logistic side, that we have the production. This is actually the company. And we have the few levels. Here we have 4, and I highlighted here the shipments from the level 2 to level 3, and in-market sales. And here you can see the easy formula how we can calculate the stock for our company is the shipments minus in-market sales and plus previous stock values. Actually, this formula, this formula used in forecasting and planning the next shipments for in actually this very business process sales planning by product manager. And on the top right corner, you can see the short pipeline of activity, how this plan actually, how the product manager works. So he gets some actual data, then communicate with manager of the client. For example, this is the mass market. Actually, in 90% is the retail. So he communicates with the, for example, some key account manager, and they have he has their insight about data. So and the next step, we need to consolidate our forecast and our plan. So create some final values for our factory, submit it with the head management team, and share the final plan with our distributor. And the main problem here is that manager, like the expert, he has a error usually about from 10 or 15% by 20. So it's not the best practice, and we want to improve this accuracy. And actually, the study, so in the study, yeah, in the title, you can see the words like predictive analytics. So is it actually the branch of data analysis methods that makes prediction about the future? And in our case, we want to predict the sales. So this is the supervised machine learning. We can use supervised machine learning algorithms because we have the data and have some like target labels that we want to achieve. So in our work, we choose the regression models that we want to test. And here you can see some applications, some tools where the people can work, the employee can work on their business environment inside the company with the different application. But in my case, I choose the Microsoft Azure Machine Learning Studio because it's easy to access. It's a cloud-based platform. It's work with many data formats and no need some hard programming skills. But as well as you can see, any tools are also can work with such problems. So here you can see, so for my experience, for experiment, we use the following features, following data. Some of them external, some of them external because of the especially some like key features of the market. We do not know a lot about our customer, actually the people who buy tobacco product because of some legal restrictions. So we use the external data about the macroeconomic in our country, and actually some internal data like number of SKU, it's number of units, tobacco products, and number of like delivery centers for our client where we actually sell our product. And we want to target value to predict the market sales. So the best variant, what I can say, it's the take all possible features for model. And here you can see the like look of the interface of the Azure Machine Learning Studio. So it looks like you take the data set, you select the labels. For example, in my case, I exclude some unnecessary tables that I collect, that I take from the company database, and then I split the data to train and to test in 70 and 30% relation. And you can see here the models. It's like the next shifted screenshot. This is the regression model and how it actually looks. We have the train model module, the score module, the evaluate module, and step by step, we calculate the metrics for our models. It's like mean absolute error and root mean squared error. And actually, after that, the simple R script just combine all data to one table to summarize the results. And here you can see the bottom of our model. It's right on the right part of the screen. This is the screenshot with the final table with metrics. By these metrics, we can say that decision forest regression works better than others. So this model has the lower error in prediction the market sales. This is the small example, like what data, how it actually looks like when we test or test our model. So we have the IMS, it's the true value and prediction value, and we see the error. And here we can say that it's lower than expertise, as I told, it's 15 or 20%. And the last slide, actually, the one of the last slide is the formula what we can do with this data. For example, we have the sum prediction for the next
1 minute.
Yeah, thank you. For the next month, and project manager, like PM, the short call, he like gets the model prediction. He see, okay, next month is like this number of units. We have some plan of shipments, and we have some stock data from previous months. What we can do, we can talk with our key account manager and, for example, understand that we're able to store no more than 450 units. So we just calculate the sum. We just take the predicted values, put it in simple formula to calculate the future stock, and we see that we have additional like ship volume that we can produce, sell to the market, and it will be enough, and we will not go from out of the limit in our stocks. So after this calculation, the management team and the project manager can submit the new plans and actually share it with the distributor. And after that, the conclusion of my work is that after we define the predictive analytics inside such company of tobacco products, it brings the benefit to all stakeholders in the business process. It was built the application that can be right now accessible for project manager and key account manager to work with, and actually it was providing the formula to estimate this additional volume, this benefit to the company. And the further study on this work would involve actually the analyzing and testing and other tools and algorithms to forecast the sales, and actually integrate the similar logic and similar application in FMCG company in other business processes. Yes, this is all. Thank you for attention.
Okay, thank you, Konstantin, for your report. Dear audience, do you have questions to Konstantin? Professor Pamphilov.
Okay, but you know, I know this particular project pretty well, so it's really difficult to ask any questions, but I can ask a couple standard questions. The first of all, you tested your solution on a very specific product, so it's tobacco product with very special characteristics. We know this is the tobacco product is completely different from milk or from any other products.
Yes.
And the first question, is it possible simply to, I don't know, adopt your approach, your solution to other products?
Yes, okay. I want to select this slide and tell, for example, if we take another product, what we need to do to just scale our application, and so it will be suitable for another product. It is can be, but the key point here is we need to take more features and maybe like take some additional steps to understand what pipeline of sales planning in, for example, particular milk, like another product business process. So, for example, it can be some tricky moments that some contracts, for example, contracts points with the clients has the limits, for example, of the amount of product that you can sell. So even if you predict some number, like you need to know that it's not actually so not so useful for you, because you have like 10 years further agreed the amount of product that you sell to the account, to the retail. So actually this can be, we can scale our application, but the first point, we need more features because it's easier to collect the data about the customer. So the accuracy will be better than with this product, with tobacco product, I think. And we need to know the contract, like points, contract features also, to be able make our application useful really for product manager or another employee.
Okay, it's just a matter of feature engineering. Some more efforts into feature engineering, and we can apply the same approach.
Yes, more data can bring better results in this case.
Okay, and maybe the second question. So you compared 5 models. So if we want to improve the prediction parameters to make it more accurate, so what can we do? Can we apply, for example, ensemble of models, not just one? So you have chosen just one specific machine learning model out of 5. But what if you combine several different machine learning models into ensemble? Can you improve somehow the prediction score?
Yeah, by using another method and another machine learning models, for example, the neural networks, or not neural networks, for example, some packages from, for example, I forgot the right name, but for example, in the Python, I know that there are a lot of also models that you can use for classification, like regression models, and make the combine and the assemble of the models. It is, we need to test it. We need to try this activity to improve the model. But the main point here, actually, that for many models, I think that better to collect more also data, because some models can work not so good with the pure columns, with pure features. Yes, but the assemble of models is also the good idea to improve the study and test it in the next step.
Okay, so thank you very much. No more questions from my side. If any new questions appeared in the audience, if not,
we can go further.
Also,
Yes, thank you, Konstantin.
Okay, thank you.
So while next speaker is preparing to share his presentation, I will introduce him to all of us. So it is Alexander Ivanov. I think that he will be by himself, from Moscow Technical University of Communications and Informatics. And the topic of his report is Introductory System of Operation Analysis and Control of Testing Stands for Aircraft Generators. So, Alexander, you are with us. Yes, now we can hear you and we can see you. So you have 10 minutes for your presentation, and before 1 minute left, I will tell you about it, and then will be 5 minutes for questions. So if you are ready, you may start
I'm ready. Thank you. My name is Alexander Ivanov. I'm a second course PTUSI Master of Science student. Automation of technological processes and production field of study. And now I want to present you the research related to the development intellectual system of operation analysis and control of testing stands for aircraft generators. One of the urgent tasks for the aircraft repair industry is intellectual operation of testing stands for aircraft generators, which make it possible to check generators after repair. The high load of testing stand, the complexity of used methods, the variability of the generators models give the large resources load on the organization carry out the repairs. There is a need for the development and application of machine learning algorithms for the development of an automated system for intellectual control of the test bench for aircraft generators. The control system for checking aircraft generators at factory stands should provide increasing the metrological identity, information content, and efficiency of testing, the maximum approximation of test conditions to real operation conditions, reduction of fuel, energy, and material cost by reducing the operating time, accumulation of an extensive database and conduct detailed analysis of the generator's characteristics, safety and comprehensive control of technological equipment, reduction in labor costs, and identification of weak points in technological processes and making recommendations for their elimination. The Python programming language is used to implement the intelligence system. Jupyter Notebook was chosen as the development environment. Jupyter Notebook is a powerful tool for designing and presenting data science project in the interactive way. NumPy, scikit-learn, and pandas are packages used to process and implement the algorithm. The task of our work is predicting critical periods of the generator life cycle. The critical period is a noticeable determination of a certain set of indicators. For the implementation of an intellectual system of operation analysis and control of the stand for aircraft generators, there is a training data set used in the article containing as input the time series of various characteristics of the generators is formed on the basis of experimental data obtained at the enterprise. Each generator starts with varying degrees of initial depreciation and manufacturing variance. The set contains over 100,000 lines and 26 attributes. One of them are unit number, timing cycles, total temperature at the fan inlet, required corrected fan speed, and others. Then the data set is divided into test and training set. By analyzing various machine learning algorithms such as neural networks, decision tree, and random forest, the random forest algorithm was chosen as a machine learning algorithm for our work. Random forest or random decision forests are an ensemble learning method for classification, regression, or other task that operates by constructing a multitude of decision trees at training time. Random forest algorithm has next positive sides. Random forest is considered a highly accurate and reliable method since many decision trees are involved in the forecasting process. Random forest doesn't suffer from the problem of overfitting, unlike neural networks. Random forest can be used in both types of problems. It's classification and regression problems. A random forest can also work with missing values. The creation of an intelligent system for analyzing the operation and control of the stand for aircraft consists of several steps. data set processing, creation of a function for training the model on the training set, analysis the result of training the model, improving the accuracy of the system, and the final step is testing the model. For the use of the data set for testing and training the model, it must be preprocessed. Jupyter Notebook tool and the pandas, NumPy, and scikit-learn libraries were used for preprocessing. As a result, the following was done. Remove attribute with empty values, check the original data type of attributes, remove attributes with constants that don't carry information about the state of the object. We use a random forest regression to train the model. You can see the part of the main block of the program code, the function for training models according to the random forest algorithm. Then you can see in the slide, and the train model on a training set. You can see the prediction graph of the result for all generators, which will reflect the curves of real and predicted values. Analyzing the graph and the value of the average absolute error, we have a good result. The predicted value curve is very similar to the real value curve. Next step is to display the accuracy of the development model. To do this, we will change the parameter max depth and estimators. That means the maximum depth of the forest and number of forest trees. Receive the graphs of the model dependence of the accuracy of the maximum depth and number of forest trees. Analyzing the left graph, you can see that with an increase in the number of trees in the forest, the error value decreases. However, when the value of the estimators parameter starts to exceed 60, the error rises sharply. In this regard, let us fix the value of the parameter estimators at field 60. The right graph shows that with an increase in the max depth parameter, the error value decreases. However, with a large maximum forest depth, the value of the average absolute error starts to increase slightly. The interval on the max depth graph is between 7 and 8. In this regard, let's fix max depth equals 7. As a result of the work, we analyze the subject area, we preprocess the data set, we may obtain a model that can be used to predict the life cycle of a generator in an intellectual analysis and control system of a test bench for aircraft generators. Thank you for attention.
Thank you. Thank you, Alexander. So you have about 2 minutes, 1.5, and it will be added to the time given for questions. So, dear guests, participants, do you have questions to Alexander? No. Peter?
Okay, if no questions, I will ask questions for sure. Okay, you mentioned that we are talking about operation analysis and control. So whenever I hear the word control, it means that we need real-time data or data which is fresh to make any control actions. So in your analysis, what kind of data you use to make predictions? Do you apply your machine learning model to historical data, or it's about fresh data, data collected in real time or near real time? So what kind of data we are talking about?
We have a real-time data that has a 100,000 lines and 0.6 attributes that the parameters of the generator For example, it's the total temperature at the fan inlet or required corrected fan speed, and it's the real life based data set.
Okay, but just maybe next slide. When we're talking about the model, you mentioned that it's a supervised learning algorithm. Supervised means that you have some data which are labeled already. With the real-time data, you cannot label this data because they are really fresh data. So how can you apply supervised learning algorithm to unlabeled data? It should be something trained before.
Yes, we trained in by our data set. We have, and we use the random forest regression for this work, and we have they train the model like this on the slide.
Okay, maybe I can put it slightly in a different way. So, do you train your model just once and then use it for all new data?
Yes,
or you change it dynamically, your model?
No, I testing my model once, and then just once, and we have to take our model and we have to take the generator and take to our model to predict the life cycle of the generator to the crash. But
okay, but I believe you should consider also the approach when you can retrain your model, because whenever we play with the real-time data, your model should be something like dynamically adapted to a new data, to a new situation. And you cannot use the same model just made once and for the rest of time you use the same model. It should be retrained, I believe. So just consider it in the future, your research, that model should be adopted to new data, to new conditions, and even to new generators. So you may have some new designs, some new devices, generators in the market, in new aircraft, and you need to change your model. You need to transform it to new conditions, new data. Okay, so anyway, thank you. Thank you very much. No more questions from my side. Also, we can move on.
Yes, thank you. Thank you so much. Thank you, Alexander, for joining us. The next speakers are Dmitry Sichkar and Lilia Voronova. Please be ready to share your presentation. Our speakers are from Moscow Technical University of Communications and Informatics, and the topic of their report is anomalies in investigation in information systems using machine learning methods. So, dear speakers, please share your presentation. Perfect. And you have 10 minutes for presentation. Before 1 minute left, I will let you know, just like 1 minute, and then will be 5 minutes for questions. So if you are ready, you are welcome to start.
Thank you. You hear good?
Yes.
My voice is okay. Good afternoon. My name is Dmitry. I'm a Master of Science of M2C. My supervisor is a Doctor of Physical and Mathematical Sciences, Professor Voronova Liliana. We want to provide you the results of the work related to anomalous investigation in information systems using machine learning methods. Nowadays there is an increase in the number of information systems, and according to Xeon's research, by 2022 their number will be more than 60 billion. Information systems can be used to provide services. The Amazon website, for example, is the part of Amazon information system that ensures user interaction with the system. So another example is our Russian the MGTS website that also provides user to the possibility to connect telephony, internet, security, and more. There are different tools for collecting and analyzing web server data. For example, the ELK stack that contains 3 different parts. So the logstash, that kind of filter for logs, Elasticsearch, that like a database, NoSQL database, and Kibana. This is platform for visualization. Splunk is also monitoring system, but the worst path of Splunk is it costs a lot. I mean, user should pay about $173 per gigabyte for analyze these logs. There are a lot of free software tools such as Python, Java, Grafana, Zabbix. So for MGTS, users interact with MGTS information system through the websites that open in web browser. The web application provides access to settings from the site. The servers contains the logic of opening the pages of the site. Anomaly detection systems contains of assessing of state of the MGTS server, which allows you to assess the current state of the most significant infrastructure indicators of the server, the subsystem of page opening time, the WebDriver framework interacts with the browser in which the page of the MGTS site are opened and measures the time of the page opening. So another subsystem is the data visualization, which using SQL query and receives information from the database and provides visual representation in the form of graphs. So the database acts as a subsystem and provides data storage of performance indicators of MGTS servers and data of anomaly detection system. So Zabbix, one of the monitoring informational systems, has extensive functionality, including agents. The agents is installed on the server and works as service. The agent allow you to get data from infrastructure indicators by interacting with the Windows internal monitoring system, calling performance monitoring. Through the Zabbix user interface, you can check the availability of the agent. So there are a lot of methods for detecting anomalies, such as logistic regression, decision-free, random forests, and neural networks. We came to the conclusion that the neural networks are one of the most popular methods for solving the classification problem. So we study considers methods of neural network classification, activation functions, and evaluation of classification reliability. So a multi-layer perceptron was chosen to implement the server status assessment system. So the basic and usual set of metrics for the server are CPU utilization, free rapid access memory, free space on disk C, incoming network traffic, outgoing internet traffic. So all these parameters are input at first layer of perceptron. So the result of the multiplayer perceptron is classification of the state of the MGTS server, stable, dangerous, or emergency. The operator analyze the infrastructure indicators of the server and receives data using queries to the database of anomaly detection system. We had 4,197 marked up rows containing server states in equal parts were received. So the training and test datasets are separated into ratio 75-25, and the highest accuracy of 89 was shown by a multi-layer perceptron with 3 hidden layers and the number of neurons 64, 128, 64. We trained model. The trained model takes server performance indicators in real time and classifies its state. Collecting infrastructure indicators allow you to assess the state of the system once a minute. To check the operability of the model with a known state of the system and input vector corresponding to the state. So at the current screen, you can see that after working of neural network, we had status 0 that equals stable or normal state of server. So conclusion was this part of the work was finished. In Zabbix was created tables.
1 minute.
For recording data from the anomaly detection system. So this system now working at one of services of GTS servers, and all indicators were visualized. Thank you for attention.
Thank you. Thank you so much, Dmitry. Dear audience, do you have questions? Please do not hesitate to ask. Okay, so I turn the floor to Peter.
Okay. The easy question at the beginning. So I know the answer, but just for you. So what kind of anomaly you are considering in your project? So I suggest you know that there are different kinds of anomalies, and you are targeting at specific class of anomalies or all possible classes. So
No,
what kind of?
I trying to find a specific kind of anomaly from performance metrics of the physical or virtual server. At this time, I using physical server, so I can collect some metrics such as CPU utilization, disk C, memory usage, and these metrics can be allowed only to this server. So if I wanna know the state of another server, I need another data set to train. So I hope I answered your question.
No, it's not. It's not about what kind of physical anomaly you are exploring. You can forget about computers or any kind of equipment, just anomaly mathematically, because you apply machine learning to specific data. So anomaly from mathematical standpoint, from the data standpoint, can be three major classes. It can be point anomaly, it can be contextual anomaly, or it can be collective anomaly. So what kind of anomaly you are dealing with?
At this this is the point anomaly at that.
Yeah, correct. Because you are doing classification, and in classification you are classifying points, and you are finding something like outliers. So if you find outlier, some point which is far away from the major cluster of points, you can consider it like an anomalous point. So this is, yeah, in this case, we can use a classification. But what about other very special anomalies? Because if we're talking about equipment, computer equipment, or any other equipment that operates, I don't know, 24 hours, 7 days. So in this case, it makes sense to analyze something like collective anomalies, so that you can consider not just a point in some space, but you consider some interval of time and behavior of the system in this interval. And this behavior is not just one point. It's a collection of points. And if this behavior is different from expected, you can consider it like an anomaly. Did you consider this kind of anomalies?
Yes, the base idea is to get, we can't take just this input parameters and try to predict them at the long period of time. So the base idea is to get one so get one data set with one parameter, which is state 0, 1, and 2, and trying to predict them at the long, at the some period of time in future. So this is just a part of the work. We are in process to predict the state in the state of the server in future, including other
No,
types
it's not about predicting state in the future. It's about process. And process, it's sequence of points in time. So it's not just something, I don't know, in the future or in the past or in the interval. It's a behavior. Process, it's not just one point, it's a behavior. So behavior of the system should be expected or optimal. And if this behavior or time series is different from expected, we may consider it like a anomalous behavior. So this is what I'm talking about. But anyway, it's a pretty interesting area of research, and any complex technical system requires, of course, it requires this kind of smart monitoring solutions so that we can detect some bad behavior or predict failure in a smart way before it happens. So this is the idea behind all this anomaly detection. So thank you very much for your presentation. And
thank you too.
so we have several machine learning presentations in this session. It's interesting from different application areas.
Yes, thank you. We have two more reports for today. So while next speakers are preparing their presentation, I will introduce them. They are Andrew Tutov and Natalia Tutova from Moscow Technical University of Communications and Informatics. And the topic of their report is analysis of data center development problems in the era of digital transformation. So yes, I see that Andrew is already sharing his presentation. Please.
Hello, everybody. Welcome. And how do you hear me? Do you hear me well?
Yes, perfect. And if you are ready, you may start.
I represent the research group from Moscow Technical University of Communications and Informatics. Our group focuses on cloud data centers. So let's start. Less than a month ago, Prime Minister Mikhail Mishustin announced a large-scale digital transformation in industry. The program of digital transformations and social sphere was already approved. All this is being implemented within the framework of the national project, Digital Economy of the Russian Federation. Large-scale digital transformation will focus on the implementation of Russian solutions in the field of IT and enterprises. Data centers play a critical role in these projects. What defines a modern cloud data center? Modern data centers are very different than they were just a short time ago. Infrastructure has shifted from traditional on-premises physical servers to virtual networks that support applications and workloads across pools of physical infrastructure and into a multi-cloud environment. Digital transformation is challenging data centers. In this report, we will look at the main problems and challenges. First, it is a global growth in traffic. Analyst firm IDC predicts 175 zettabytes of data globally by 2022. This data should be not only stored, but also processed in real time. The latest events with pandemic have resulted in increased volumes of data generated from various sources, such as working employees from home. The next slides show us how the demand for cloud application has grown. The cloud computing environment is an actual hero in the COVID crisis. There is an ongoing research challenge concerning maintaining data, guaranteeing quality of service, the availability and rapid deployment of cloud applications. The generation of stream data from the Internet of Things sensors and cyber physical systems are deployed. The amount of such data will grow many times over and could exceed the amount of data available on Internet, in enterprises, and in mobile clouds. Some IoT and smart city applications require feedback, such as video from millions of cameras, self-driving cars, and drones. This makes the latency and bandwidth between the network edge and the cloud a significant limitation for performing analytics. Therefore, edge of fog computing has emerged and is beginning to complement cloud computing on edge devices. The need to process the big data generated in recent years and the increase in computing power have led to the development of the field of artificial intelligence. New machine learning models and algorithms are being developed in various applications. A cloud data center is a platform for hosting machine learning services. In addition, machine learning is used to more efficiently use cloud services and the infrastructure of the data centers themselves. One of the difficult and current research areas is the creation of reusable machine learning models that can be used by multiple users in different contexts. Cloud service providers and platforms are fragmented. Therefore, the interaction of clouds remains as an open problem. Mechanisms are needed to share computing, storage, and network resources of different clouds. Cloud interoperability should be seen as the ability of public and private clouds and other heterogeneous systems to understand system interfaces, configurations, forms of authentication and authorization, data formats, initialization procedures, and application configurations. In general, approaches can be classified as federated cloud computing. There is an urgent need for new ways of delivering cloud services with guaranteed performance and resilience to deal with all types of independent and correlated failures. Security is a major concern in on all IT systems, and cloud computing is no exception. There is an annual increase in hacker attacks. In Russia, the number of cyber attacks in 6 years by 2019 increased almost 16 times. The major problem remains power consumption. Data centers consume significant amounts of electricity, more than the entire aviation industry. Data center infrastructure must be built to cope with potential peaks that rarely occur in practice. This leads to insufficient utilization of some of the data center's resources. Rapid improvements in energy efficiency have, however, helped limit energy demand growth from data centers and data transmission networks, which each account for about 1% of global electricity use. Nevertheless, strong government and industry efforts on energy efficiency will be essential. Idle servers need to be powered off as the cost of excess capacity is significant and includes the cost of additional capacity for cooling, power distribution, generators, uninterruptible power supplies, and so on. Engineering systems consume a significant proportion of the electrical energy of the data center. Most of the cooling system accounts for an average of 40% of all energy costs. These advantages of cloud computing can only be realized if the infrastructure supports scalable services and resources, as well as the ability to dynamically add and remove resources, depending on the load and the so-called elasticity. Virtualization allows you to flexibly flexibility scale virtual machines resources to meet the needs of your applications. One of the most important research tasks related to elastic services is the ability to accurately predict computational needs and application performance under various resource allocation schemes using workloads models when making resource management decisions. In order to cope with the described challenges, it is necessary to increase the efficiency of resource management of the info communication systems of data centers. To date, there is a large number of works devoted to modeling and assessing the performance of info communication systems and networks and improving the efficiency of their functioning. However, in these works, only certain issues of optimal allocation and management of resources are considered. The above discussed problems and challenges of modern data centers in accordance with the goals of large-scale digital transformation project using domestic software led us to the need to develop a main cycle of work on managing the computing resources of data centers, which includes models and methods for the initial and dynamic placement of virtual machines, as well as horizontal scaling, which allows to reduce energy consumption, meet the quality of service requirements of cloud services specified in SLA agreements, and ensure the stability of cloud service. The developed main cycle of work on resource management of the data centers and communication system, taking into account multi-criteria optimization of its main characteristics in live migrations of virtual machines. The proposed models and methods are detailed in our works. On this picture, you can see our conclusions of this report. Thank you for listening. I'm ready to answer your question.
Thank you, Andrew. Thank you so much. Dear audience, do you have questions to Andrew? You're welcome. But if there is no question, Peter, I give the floor to you.
I have questions. I know pretty well data center problems and all kind of peculiarities. And you know, Gartner just recently, they made some research on data centers, and they discovered that 50% of CPU power and 60% of memory in data centers are underloaded and underused. So it's a big problem with data centers. We have these huge factories, I would say. And you mentioned that they consumed a lot of energy. And we know that performance of data centers is measured not in flops, but in megawatts and kilowatts. So the question is, do we really have a future for data centers if they are underused in reality?
As I told, data center infrastructure must be built to cope with potential peaks. Of course, they rarely occur in practice. But at the initial slides, you can see the IDC predicts, and their traffic will rapidly grow, and 175 zettabytes of data globally in 4 years. It's very serious for all data. And we have cyber physical systems, Internet of Things field. All of this will need to be stored and processed in real time, and it can be done in data centers only. So the field of data centers will be grows and grows.
I disagree.
The last study of maybe IDC, I don't remember well, shows that Russia is on the 10th position by the quality of data centers all over the world. And we have in Russia very small data centers to compare to United States or China, for example.
But
so,
you mentioned that we need to process data in real time. Data centers are not designed for real-time processing. They are designed completely for different purposes. For cloud services, yes. For cloud applications, yes, but not for real-time. Because
maybe
data travel from data sources to cloud, it takes not milliseconds, it takes seconds and minutes. And you cannot process data in real time if you rely on data center. It should be processed close to the source of data.
Maybe, but cloud application are hosted on cloud data centers.
Cloud application, yes, but not real-time applications. Cloud applications, yes, why not? Databases, web servers, but it's not a real-time.
Okay, we can discuss this matter after our conference.
Yeah, sure. Okay, thank you very much. Thank you very much for your presentation. And yeah, also, do we have more? I think so.
Yes, we have the last report for today. And while our speaker is preparing his presentation, well, Andrew, thank you. Thank you so much. You may stop sharing your presentation. So our next speaker is Polina Bortsova from High School of Economics. And the topic of her report is Smart Maintenance, Repair and Overhaul Service Development for Aviation Health Monitoring Application. So Polina, you have 10 minutes for your presentation. Before 1 minute left, I will let you know, and then will be 5 minutes for questions.
Thank you very much.
So if you are ready.
Yes, can you see my screen?
Yes, we can see your presentation, but it's not on full screen. No, never mind. It's okay. You may start.
Yes, good day again, dear colleagues. It's a great pleasure for me to be here today with you. And I would like to present you the results of the study conducted by me under the supervision of Peter Panfilov on the subject Smart MRO Service Development for Aviation Health Monitoring Application. So the main goal of the presented study was to make the theoretical research for the service development, consider approaches to unlocking the potential of spatial and visual computing. The designing of the framework has begun with a suggestion of the integrated framework, including existing geospatial solutions for the future intellectual transportation systems. Intellectual transportation systems is an overall topic that includes smart aircraft engine maintenance that is in the focus of the study. The overall idea behind the ITS is to improve decision-making, particularly in real time, by vehicle operators, transport network controllers, and other users. ITS is an integrated system that implements a broad range of computing, control, vehicle sensing, and electronics technologies. There is a list of challenges in ITS that were compiled from different sources. And among them are improvement of decision-making, improving safety and situational awareness, taking full advantage of multi-sensor data, improving visual perception, and guarantee effectiveness of vehicles at its paths, what is very important for the current research.
Lena, please run your presentation. You don't change slides.
I run it actually.
Full screen.
Can't you see it?
We can see your presentation like in app. Yeah.
And now?
Downloading. No. We can see a presentation in PowerPoint.
Just a second. Can you see it now?
Yes, much better.
It moves.
Yes.
Yes, so yes, we just have spoken about intelligent transport systems, and now also about the challenges. And now let's move to the avionics and aviation part. So although avionics and control technologies have produced continuous advances in aircraft systems, there is still significant opportunity for challenging the infrastructure. Using big data and analytics together with secure communications capabilities, it will open us a host of possibilities to monitor an aircraft components and onboard equipment. Real-time data enables aircraft operators to apply predictive maintenance to monitor, for example, the broken parts. So more and more value is being extracted from aircraft data, delivering intelligence, analysis. Data can be unlocked from actually every part of the aircraft, cockpit, cabin, engine, and used for enhancement of performance and service. Now, the MRO in aviation, I just want to repeat that it's about repair, service, inspection of aircraft components. New technologies and utilization of services are creating big benefits for airline. But the modern digital technologies such as spatial and visual computing can offer desired smart MRO. So let's explore these technologies and their capabilities in more details. Spatial computing is primarily the ability to relate the location and space of one object to its operational control or its virtual complement elsewhere. From a practical point of view, it's a digitalization of the actions of machines, people, objects, wherever we want. The key difference between traditional and spatial computing is the orientation of spatial computing on the three-dimensional coordinates. Visual computing in its term is a field of computing that deals with the question analysis and synthesis of visual data using computer resources. It's used to visualize results. It focuses on the management of activities and interactions. Spatial computing and augmented reality together provide architecture with an ideal and realistic view on the space. People process information much faster when it's presented virtually. Maps and other location illustrations can create a powerful tool for entrance in the world of big data and digital transformation. Almost all of the application of spatial computing needs the support from the visual computing part, and the intersection of these two technologies emerges the IA, that is immersive analytics, and it seeks to understand how immersion technologies based on spatial computing can be used to create more intuitive and efficient visual structures. Combining multiple data sets with physical locations creates a rich model for data analysis, and platform for stakeholders to view and understand very large amounts of data. In our study, we consider those components that can be included in the universal integrated data analytics framework firstly. And we have here location-based analytics, maps, and user interface. That is all presented on the conceptual view of the system on the slide. Please note that the proposed solution features are exclusively open source solutions. That is important for versatility. Now more about the architecture of the system. The architecture is to provide a web-based system, a web-based user interface by developing spatial temporal analytic and visualization services. So we have here big geospatial data, big data system, big data storage, big data analytics, and also big data visualization with focus on temporal spatial data. On the next slide, we begin the next part of the research, and we move to the discussion concretely of the smart MRO service development for aviation health monitoring. Within the framework of the research, the main interest is put to the information flow between the parties that you can see in the figure 2. The network structure highlights that in case of introduction of integrated framework, real-time exchange of data and computing nature of information are important requirements. And the second figure provides a high-level conceptual view of the aircraft health monitoring practice, as it was described by ICF. Based on the analysis of the domain, some digitalization initiatives were formulated. All of them are listed here. The most important of them are that we are going to present an automated and secure transparent system of digital reporting also for aircraft engine monitoring that is based on the processing of engine status that we receive from sensors, building a model for preparing accurate predictions, profound data analytics, and collecting fleet data. From the operational point of view, the project may contain the following application parts: dashboard for engine location tracking for managers at OEMs, airlines representatives. Also, it can be as an application, a digital twin of an aircraft engine, and AR application. On this slide, you can see the prototype of a smart MRO system and how we receive data from the aircraft engine, the data analysis parts that will be included to solve the issue. The mock-up of the data visualization framework, what features will be included in it, and how we are going to deal with it, and what are the key benefits that we want to receive. The visibility of the system status, user control and freedom, helping of users to recognize and diagnose errors. Here are also some words about the AR application that is going also to be developed. The key benefits of this are better ramp handling, faster ramp operations, enhanced communication, convenient data access. To conclude, should say that the research on the technologies of spatial and visual computing for modernization and optimization of MRO was conducted. The framework was described, and it was proved that it's suitable also for the issue of MRO. Also, in this research, it was understood that spatial computing promises to be transformative in other spheres, so like smart health, smart transport, and smart cities, and overall smart environments. And in these frames of the work, it was revealed that it's advisable to carry out digital to pay more attention on the to pay more attention on the benefits that spatial computing can give some enterprises by going to this digital transformation.